Welcome to Standing for Truth. My name is Donny Budinsky, and I'm thrilled to have you join us for today's exciting and eye-opening program. Carbon-14, a creationist best friend. Science confirms a young Earth. Today, I'm joined by Helmut Welke, who will walk us through the remarkable evidence surrounding Carbon-14, one of the most important and revealing scientific tools in the origins debate. What does Carbon-14 actually tell us about the age of fossils, coal, and even diamonds? And why does this evidence point so powerfully to a young creation rather than millions or billions of years? We'll examine the data, uncover the assumptions behind conventional dating methods, and expose why every rescue device used to defend deep time falls apart when Carbon-14 is put to the test. The evidence is in, and it's clear. Carbon-14 confirms the truth of God's word. So stay tuned. This is going to be an informative, faith-building, and game-changing presentation right here on Standing for Truth. Helmut, my brother, it's great to have you back. Welcome to the program.
Thank you, Donny. It's great to be here again.
Well, I'm looking forward to this. This is not your first rodeo. This is, I believe, your fifth time here. You've blessed us with a lot of your work and material, aliens and UFOs way back in the day, it seems, Adam, Eve, and genetics, transitional fossils, biblical cosmology. I think that was the last one you were here for. So always great feedback with your programs, brother. But we are always getting new subscribers, new followers, and supporters. And so for anybody who might be unfamiliar with who you are, before we get into your presentation, I'd like to give you a formal introduction. Mr. Welke is a retired engineering manager, having worked in a variety of U.S. and international assignments with a Fortune 100 company. In 2006, he was elected to the board of trustees of an international society serving the industrial and systems engineering profession. He holds a U.S. patent and is well versed in the use of science to design and manufacture advanced products. His bachelor's and master's degrees in industrial engineering were awarded by the University of Illinois at Urbana. Am I saying that right? Urbana? I'm Canadian, remember. Okay.
Okay.
In 2012, he was elected a fellow of the Institute of Industrial Engineers. Helmut is a member of the Creation Research Society and an ambassador for Logos Research Associates. He recently was elected president of Creation Summit. Probably not so much recently now, given when this bio was wrote.
Yeah.
An organization that seeks to bring the truth of creation to college campuses through seminars and organized debates. He has presented creation science in schools, churches, and at civic organizations throughout the United States, plus France, Poland, and Germany. We were just talking, brother, how many speaking engagements you've just had in Germany. Helmut has been looking at the creation evolution question for over 30 years and wants young people everywhere to hear both sides of the issue. Helmut, before we get into your presentation, though, if you could, for the audience, just briefly, you've been really busy. I've seen pictures and stuff on social media. You've been speaking and upholding the truth of biblical creation, which is what we love to do here over in Germany. How has that been? Has that been fruitful, brother?
Oh, really? It really has. And God has just opened up so many doors to the point that I get worn out. But God gives me strength. And on this most recent trip, I gave about 18 presentations in 14, actually more like 12 days if you exclude travel days. So yeah, schools, big conference, churches. God has opened up the door, and people are hungry for the truth. I spoke at a couple of brand new churches where I'd never been before, including the youth group on a weeknight evening, and they had a good turnout and a lot of good questions. And I think we were scheduled for an hour and a half, and we went almost 4 hours. So
wow.
good questions, a lot of interest, and afterwards we got excellent feedback. So yeah, it's growing. I've been going to Germany doing speaking tours now for 10 years, and it's really amazing how God is opening more and more doors. Places that weren't so sure about this topic are now welcoming it, and really amazed at the answers that God has provided. So it's exciting. The
Praise,
gospel is being preached, because if you can trust Genesis, you can trust Matthew, Mark, Luke, and John with the gospel truth.
amen. It's directly connected. It all brings us back to the gospel. Praise the Lord. That's awesome. Excellent endurance. What you thought was going to be an hour and a half went 4 hours. And we got to get this information out there around the world. So I appreciate you doing that, Helmut. That is awesome. And okay, there's a lot of excitement. Like you said, there's a lot of excitement here as well. I'm looking forward to this. Carbon-14, a Creationist best friend. Helmut, I've got your introductory slide on the screen, Science in the Age of the Earth, it says. And so, brother, the floor is all yours. Go ahead.
Okay, well, thank you. I really appreciate it. And yeah, sometimes I call this talk Carbon-14 in the Age of the Earth, but I do bring in a lot of other evidences, particularly in the last third of it, in fact. So I just called it Science, the Age of the Earth, but it's primarily, we're going to address Carbon-14, because I'm sure a lot of people in the audience, when you hear Carbon-14, they think, well, that proves millions of years. All right, we've all heard Carbon-14, hydrocarbon, whatever you want to call it, the same thing, in the same sentence with millions and billions of years. Well, that is not true. People don't understand Carbon-14, so we are going to set the record straight on that. And we're going to compare, basically, the creation model, which if you go with a straightforward reading of the Bible, the book of Genesis, God created the universe and everything in it in 6 days, not too long ago. Man, at the end of that week, was created in the image of God. So we are unique. We have a basic morality that all of us has. I attended this panel discussion on morality, and atheists tried to say that, well, we evolved our morality. No, that doesn't make sense. I mean, that's for a person who doesn't understand evolution and the tooth and nail theory that it is. You are not going to create a conscience in a being that's created separately from the animals just through the evolutionary process of death, disease, and dying from millions of years. You can't do that logically, even though they have faith in it, because they recognize we have a moral. Of course, the creation model would say the reason we have a conscience, the reason we have morals and believe in them, even if we sometimes, burn through them and try to, through greed, get ahead, breaking our own moral system. But we have that latent memory of being created in the image of God. Of course, why do we have sin and death and lying and cheating on our own conscience in the world? Well, that's because of sin. Sin is the cause of death, disease, and the problems in the world. And that went rampant at a point in history not that long ago, where God destroyed the entire world by a worldwide flood. And so God, and a lot of reasons, we'll get into this briefly, is that our culture doesn't want to believe in a worldwide flood because it's so obvious a judgment of sin. And that's what they're trying to avoid. So the creation model does say, not that long ago, God spoke all things into existence. And as I mentioned, sin is the problem, but God shows his love for us, and that while we were yet sinners, Christ died for us. So he also offers us the solution if we accept Christ. Now, a lot of people have rejected this model, don't want to be held accountable for sin, either on a worldwide general basis or individually. And so our culture has drifted to this evolutionary model, and it's coming basically up to about 15 billion years ago. The universe exploded into existence. About 4.6 billion years ago, the Earth evolved from swirling gases somehow. And then 3.5 billion years ago on this early Earth, after a long time, life evolved, and death is part of the evolutionary process. You had to have death and disease for millions of years, as Carl Sagan used to say, for us to get to where we are today with all kinds of advanced animals, plant life, don't forget those plants, as well as human beings. And of course, we evolved from some ape-like creature. In other words, time, chance, natural processes is the evolutionary model, as opposed to God doing everything, which we then have to look at the evidence and what fits better. So the whole question of millions of years, what we're going to do in this talk is see that science, and I'm talking about empirical science, does not require millions of years, but it's a necessity for anybody to believe in uniformitarian geology. In other words, no major catastrophes like a worldwide flood. Everything is continued on uniformly for eons. And of course, that then gives a time frame for the evolutionary theory. We'll see that science doesn't require this. Of course, where did the idea come from? Well, it really picked up steam. There's always been some variations in history of man since actually the Greeks. But one of the things that really got going is as people looked at geology, secular people a couple hundred years ago, the varves are those tiny little sediments within rock layers and strata. And that, you know, every tiny layer could be a year or hundreds of years, almost like counting tree rings on a tree. And that you would add them up in a giant cliff face where you have lots of varves, lots of sediments. You know, you get millions of years, and then the bigger the strata, up to a mile thick or more, you can get into the billions of years. And the obvious idea here is there's long been this mantra in geology that the present is the key to the past. In other words, what's happening in the present explains everything. And if you force that assumption, then yeah, that's how they logically came to long eons of times, millions and billions of years. That because sediments are being built up slowly in lakes and streams and the mouths of rivers, and they're going up slowly. And so that happened only slowly as it is today. Then it must have taken millions of billions of years to build up these giant rock strata that we see all over the world. That's the uniformitarian view made popular by Charles Lyell. There are lots of others, but he's the key culprit there. And he was a correspondent, a friend of Charles Darwin. Of course, the cataclysmic view, there were even the time of Charles Lyell, there were geologists who were actually doing better work than Lyell. And they said, no, these sediments are a result of Noah's flood 4,500 years ago, so maybe 6,000 years of total human history based on the genealogies of the Bible. Well, Charles Lyell, he got an award for being a geologist, but he started out as a London lawyer. Lyell convinced the world that slow and gradual geological processes would end up giving us eons of time, and that Noah's flood never happened and Genesis can be set aside. That's what he convinced the world. It's what he convinced Darwin of. And Darwin, of course, took those millions of years and turned it into biological times periods needed for the evolutionary thought. So as we look in the past, recent past, we can go back to the 17th century, and there were still strong people even writing books like Niels Steensen that basically affirmed an old Earth and that all the fossil-bearing rock, which we were beginning to explore, was a result of Noah's flood. But in 1795, James Hutton, who is also a Scottish man, a very unscrupulous young man, actually, if you get into his history, but he tried to explain history by what is happening now. And by the 1830s, Charles Lyell picked up on that idea, wrote his book, Principles of Geology, The Present is the Key to the Past, and that Noah's flood, if there was such a flood, it was only a local flood, which is a story we still hear today. Well, then in the 1830s is when Charles Darwin did his voyage around the world, and he started as an amateur geologist. He took the idea of millions of years and then spread it into his book, 1859 book, Origin of Species Through Natural Selection. So that's, without Charles Lyell building on Hutton and others, there would be no Darwinian evolution because it needs millions and billions of years to even be remotely plausible. And of course, Darwin corresponded with the German a scientist named Haeckel, and Haeckel wanted to help Darwin, so he provided these fake drawings, and that we know they are fake, even though they're in high school textbooks still today, proving that our embryo goes through the evolutionary stages, from a fish to a frog to a chicken and so on, which is totally false. No embryologist believes that. And we know Haeckel faked the drawings, but it's part of Darwin's story. Well, we have this period, this 100-year period between Lyell and the early 1900s, where people were beginning to believe in millions, and later they graduated to billions of years, but let's just go with the millions. And that was to accommodate Charles Lyell's assertions, and then, of course, Darwin's belief in biology. 1905, we actually have the first hints of radiometric dating, and then 1912 to 1953, over 40 years, people believed in Piltdown Man, which we now know was a fraud, but that was used to confirm generations of scientists that Darwin's idea was true. And once you believe that, you need the millions of years. Now, carbon-14 actually didn't come around till the 1950s. And we'll get into that just to explain a little bit more on how it's used and abused today. But the evolutionist Stephen Gould, he has written a lot about Charles Lyell, the London lawyer, and his book, Principles of Geology. And Gould admits he says his book is one of the most brilliant briefs published by an advocate being a lawyer. Lyell relied upon true bits of cunning to establish his uniformitarian views as the only true geology. First, he set up a straw man to demolish. In fact, the catastrophists were much more empirically minded than Lyell. The geologic record does seem to require catastrophes, and more geologists today are admitting that. They truly are. They're seeing that Lyell and his uniformitarian strict views were wrong. Now they just talk about many catastrophes because they still need the millions and billions of years. But the point here is, if you really believe in millions and billions of years, then you've been had, at the basis of it anyway, you've been tricked by a London lawyer. Because it certainly is not because of hard scientific evidence that we need this. We need it for Lyell's views and, of course, Darwin's view on the evolutionary thoughts of biology. In 2 Peter 3, this is St. Peter's last message to the church. He gives a little bit of a warning. Know this, first of all, that in the last days mockers will come with their mocking, following after their own lusts and saying, where is the promise of his coming? All continues just as it was from the beginning of creation. So whatever creation account you want to go with, all continues just as it was. This is Peter's prophecy that people in our time will believe in this uniformitarian, that all continues just as it was from the beginning. They will ignore Noah's flood. And Peter goes on and says that, for when they maintain this, it escapes their notice, on purpose, I would say, that the world at that time was destroyed, being flooded with water. They want us to forget about a Noah flood. But what Lyell and his believers even today, they don't have good explanations, at least none that make a lot of sense. They do have some, I have to say, but they have some. But Lyell didn't know about marine fossils on top of fountains. The Himalayas, you can find mollusks and seashells, all kinds of fossils, most of the Rockies, Chilean Andes, and others. He didn't know about fossil graveyards all over the earth, where you have dinosaur bones mashed up like they were in a big mix master and then swoosh, plopped down and then dried out on various sites around the world, particularly in the Northwest United States, in China, and in several other locations around the world. And of course, mixed in are sea fossils. In fact, 95% of all fossils are marine fossils, plants and animals. And he didn't know how fast you had to be buried. Here's a fossil of a ichthyosaurus giving birth. I mean, it had to happen fast. And of course, quick and deep burial. Now, fossils and all the dinosaur bones, they don't come with a tag on them, you know, made in ancient China in 65 million years BC or Montana in 80 million BC. No, they don't come with any tags. And of course, they can't use radiometric dating on the fossils. What do I mean by that? Well, there is no direct dating technique for sedimentary rocks, and that's where the fossils are. You cannot use potassium argon, you cannot use even the carbon-14, you cannot use uranium lead on sedimentary rock. Most of those are only used on igneous rocks, rocks formed by heat. And of course, carbon-14 is a little unique. We'll get into that because you can use carbon-14 on fossils. But my point here is it wasn't hard scientific data like from radiometric dating that people hear about today that led to these millions of years. It was a necessity for Lyell and Darwin. So here's Andrew Noll, a Harvard paleobiologist. He said, a great achievement of the 19th century was learning to use fossils as distinctive time indicators. That allowed this wonderful scale to come into being. You are using fossils to date where and how old the rocks are based on where we find them, the type of fossil, and that gives us the dates for the wonderful scale or the geometric time scale, the geological time scale. So what's an index fossil? Here's a good definition. It's any plant or animal or plant preserved in the rock record of the earth that's characteristic of a particular span of geological time or environment. Index fossils are the basis for defining boundaries in the geologic time scale and for the correlation of strata. So in other words, it's an index fossil. If you find this fossil in a certain type of rock, and then you look it up in the book, and the book will tell you, oh, if you find this fossil, it's going to be 45 to 80 million years old, or more specific, let's say 65 to 80 million years in the dinosaur ages. And I have seen index fossils even used for rocks over 1 billion years. How do they know these rocks? These are really supposedly ancient rocks, 1 billion years old. Well, they found a certain type of microscopic fossil. They look it up in the book. The book says, there it is. That would be at the bottom of this geological timescale. Now, one of the most widely used index fossils is an ammonite. Most of us have seen ammonite. These are fossils that you can find that we have found by the millions. They're all over. And they say that since we're only finding them in the same rocks as dinosaurs, that if you find an ammonite fossil in a sedimentary layer, then you look it up in the book, and it's going to be roughly, 60 to 200 million years old. Millions, hundreds of millions of years old. Why? Because I found an ammonite fossil in it. Then the logic then says, well, anything you have in that rock layer, that strata, is going to be that same age. And of course, there's lots of index fossils. Here's just a recent table. You can see it goes all the way down to Cambrian levels. That's where you get into the billions of years. You find some of these microscopic fossils, and of course, for the ammonites, you've got different types there to try to separate between the Jurassic and Cretaceous period. You find that fossil, that rock is 65 to 80 million years old. And of course, that's where we find dinosaur fossils. We cannot date normally the sedimentary rock or the fossil that's found in it. Now, yes, you can date using some methods of if you find volcanic rock, like volcanic ash or lava flow within the sedimentary rock, you could use some of the older methods on that, but we're going to get into that. We'll get into that. So basically, in the American Journal of Science, an article was stated, to sum this up, The rocks do date the fossils, but the fossils date the rocks more accurately. Radiometric dating would not have been feasible if the geologic column had not been erected first. And that's what that other quote was getting to. We have this faith, this belief in evolution. We need millions and billions of years. So we start making this column and use the fossils to date the rocks. But the rocks also date the fossils. Can you see the circular reasoning? And it's literally this way. Now, if you take away all the the fancy scientific jargon, you're ending up with, well, how do you know this sedimentary layer where I got a dinosaur bone is, 70 million years old? How do you know that? Well, I find these fossils, and these fossils say that this layer is 70 million years old. Well, how do you know the fossil is that old? Well, because we find it in layers that are 70 million years old. Well, how do you know the layers are 70 million years old? Well, because we find this fossil, which are 70 million years old. You see the circular reasoning. That is literally what's going on today. And a lot of the long-age dating techniques, which were developed after the belief in long ages was accepted as true, they came after that. And they were basically cherry-picked to match the prior assumption. So belief in millions of years was not based on empirical science, but on an agenda to discredit the Bible. And Charles Lyell basically admitted that in letters to his friends. He wanted to discredit the Bible, particularly Genesis. So what about radiometric dating, something we've had more recently? Well, some of the methods are handpicked in the 20th century to match long-age beliefs. They picked the ones, they cherry-picked the ones that gave him the right answers being based on my assumptions on evolutionary theory and how long all this must have taken. It's kind of the reverse method. We're going to also see some inconsistent results. And that is because of faulty assumptions. Now, all of these methods need assumption. You can't know everything in the background of a rock, no matter what kind of rock it is. So you have to make some assumptions even when you use any radiometric technique. Assumptions is a key thing to remember. Now, when I was working, we had to, a group of us who were working on new factory layouts and some advanced manufacturing techniques and process improvements, we had to read a book which is now considered a classic called The Goal. And this book by Eli Goldratt is basically a storytelling book that presents process improvement. It's about a consultant who's hired by a factory manager. The factory manager works with the consultant, and they go through a whole bunch of stories, questions, and basically lead you how to improve your processes, whether in a factory or some type of a system that's dependent on processes happening correctly, and trying to speed up the process so that you can meet the needs of your customers quicker. Anyway, I read this book and I was struck by a quote on page 157. Now, in this book, this is Jonah. He is the consultant, and he's called in to help Alex, the factory manager. And so they're discussing a particular issue and the backgrounds. And Jonah says, when I was a physicist, people would come to me from time to time with problems in mathematics they couldn't solve. They wanted me to check their numbers for them. Okay, so he did. But Jonah says, but after a while, I learned not to waste my time checking the numbers because the numbers were almost always right. However, if I checked the assumptions, they were almost always wrong. Wow, does that stand out to you? In all of these techniques and a lot of things in what we do in life, people have a little trouble, maybe the math, and they're trying to figure out a complex problem, and they don't like the answer, or it can't be right based on some other data. So we check the numbers, but the mathematics, the actual calculations are correct, but you have to make some assumptions along the way in almost every case, especially when dealing with the past. So if you check the assumptions, and in this case, Jonah said, they're almost always wrong. And that's why the answers made no sense. So remember that. Look for the assumption when you hear crazy things, claims about why the Bible can't be right about something. Well, what are the assumptions? Your math might be correct, but the assumptions you used. Now, radiometric dating has a lot of significant assumptions that you cannot be sure of. And, just to be able to make the calculation, you have to make some assumption. That's not unusual in science, but you should be upfront and talk about some of these assumptions because they do seem to have problems. For example, if you have a sample, it's got some uranium and lead, and you want to use the uranium decay rate to lead. Well, how much in the original rock, when that rock formed, how much uranium was in it to begin with? And then along with it, the daughter element, uranium decays to lead. So we just generically refer to the uranium as the mother. It decays over a series of processes, and you end up with lead, an inert metal, and that's called the daughter element. So how much of each do you have to begin with? That's an important question. Most of the time, the assumption was, well, we just began with lead, and all the lead, we began with uranium, and all the lead we find in this current rock over this millions of years, it occurred and was formed in this time, and that helps us calculate. If you don't know the startup amount, you make some assumptions. Now, they've gotten more sophisticated than that, but it's still based on a long series of assumptions, even if they don't start with zero lead in the original rock when it formed. But here's the big kicker. You've got to assume that it's the amount that you measure today was not disturbed for up to billions of years. It's got to be a closed system. And yet we know water leaches through rocks, and that can bring in extra lead or uranium. It can bring in or take out to the other rock layers the same thing. We know that happens. And yet this assumption has to be somehow part of the calculation. Otherwise, you just throw up your hand and say it's unknown, which is probably the best answer. And of course, the decay rate, we can kind of get a handle on that today, even if it's over millions of years. How do you know that has been constant? A lot of scientists today believe that the decay rate went through a startup fast period, and therefore what we measure today makes these numbers look eons long. So really, when we say, especially news articles pick up these rock layers or these items were picked up based on radiometric dating is billions of years old, we should ask, well, what are your assumptions and how do you know they're true? Here's an example. This is one that used mostly on lava and volcanic ash, potassium to argon. There's also an argon-argon method. They're all kind of related. But it all goes back to how much of a certain type of argon do you have to begin with. And now we know that argon is found to be present in fresh lava. They used to think that when lava rocks came out of a volcano or some underground flow of molten rock, it didn't have any argon gas. And that you could then check on how much argon is in it today and then calculate backwards how old that rock or that volcanic rock is based on the potassium to argon decay rate. But we know that assumption is now wrong. I'm not going to get into a lot of details. I'll give you some examples though. But just to put all this about the different radiometric dating methods in perspective. The long ages, there are others, but these are the primary ones that have been used for decades. Uranium to lead, potassium to argon, rubidium to strontium. Those give you the long ages, 200,000 plus years to millions, hundreds of millions, even the billions. But they're only good on igneous and metamorphic rock. You cannot use them on sedimentary rock, and you certainly can't use them on fossils. That's where the long ages come from. So when you hear about radiometric dating, and people even throw in carbon-14 into the mix, think it's all the same, proved millions of years. No, it hasn't. You can only use it on certain types of rocks to get the millions of years. And here's the interesting thing. When you do check on some of these methods, they're almost always wrong. And there are more conflicts than agreements. In fact, researchers will throw out radiometric dating if it doesn't give them the right answer, and then use use some other method, such as just going straight to the type of fossils or index fossils and say that's the right answer. Note again, there is no method for sedimentary rock where the fossils are. Now, what about carbon-14? First, it has nothing to do with millions of years. It's only good for up to about 80,000 years, and it can only be used on something that was once alive. Now, I'll explain that in a minute. So a fossil was once alive. Yeah, you can use carbon-14 on a fossil. And if you have carbon-14, since it's only good up to 80,000 years in the thousands, you cannot use it on anything that you believe is millions of billions of years old. That's why paleontologists who believe in millions of years, that the dinosaur bones, for example, that they dig up are 65 to 80 million years old, they will never send it to a carbon-14 lab because they believe, they have faith with all their heart that these fossils are billions of years old because they found ammonites in the same rock layer, the index fossil for them, or some other related item. But they won't send it to a lab. Why spend the money if I know it's going to be 60 plus million years old? Carbon-14 can't tell me anything. However, as we'll see, anytime that a dinosaur fossil has been sent to the lab with carbon-14 dating, it comes back with an answer less than 80,000 years. It does not come back, oh, zero carbon, cannot tell. No answer. Carbon-14 dead, no answer provided. It comes back with numbers in the thousands. So carbon-14 dating methods, how it works. Where does carbon-14 come from? Well, when cosmic rays, or just general space radiation, hits our atmosphere, which is mostly nitrogen, when it strikes the nitrogen, some of that nitrogen can be turned into carbon-14. It loses a couple of electrons, the atomic weight is the same, but now it's got the atomic structure of carbon, a radioactive form of carbon, which is normally carbon-12, but we now have a carbon-14 molecule. Carbon-14, like its cousin carbon-12, can form with oxygen combined and make CO2, just like normal carbon does in the atmosphere. And so that means this carbon-14 bonded with the oxygen is in our entire food chain. Plants take in carbon-14. And of course, they need that. They need CO2, a certain very small percentage, but it's there, of that CO2 is made with carbon-14. So it's in the plant life. And an animal eats that plant, or we eat a nice salad, that salad has carbon-14, plus the air we breathe has a certain amount of carbon-14. So everything that is alive at any given point has the same amount of carbon-14 in its system as is in the atmosphere. And so, if you're a meat eater, you have a nice steak, well, you're going to get up some of the carbon-14 that animal, whatever, had in its system, and it hasn't been dead that long. Certainly, I would hope not for 80,000 years. So it's going to be part of what you eat, part of what you breathe. You eat the plants, they've all got the same carbon-14. Now, the thing about carbon-14, it has a short half-life, 5,700 years, we'll see. And it decays back to nitrogen-14. It's called beta decay. And over thousands of years, it goes back to N14, and everything is fine in this cycle. But as long as anything is alive, it's going to get new carbon-14 by breathing and eating. And as the carbon-14 that's in the system is slowly going back, and you hit a kind of a stable point where the carbon-14 you take in roughly matches the carbon-14 that's decaying back to nitrogen-14 and just goes back to the atmosphere through our normal bodily systems. So what is the starting point? First of all, know this. If you find carbon-14 in a sample, it's only thousands of years old, up to a maximum measurable amount of 80,000. So let's say we have here an example of a starfish. When it's alive, living in the ocean, there's atmospheric carbon-14 everywhere. We're going to have it. And so that ratio of what's carbon-12 to 14 that's in the atmosphere at the time of death is what's in that animal, plant, what have you, including us. Then it becomes a fossil, and it starts to change because the carbon-14 that was there while the plant animal was alive is decaying, but it's no longer taking back carbon-14. It's no longer eating, breathing, and so on. So what we need to know, how many half-lives have expired? That's how we calculate this. How fast is decays? This is pretty well known at 5,730 years. Carbon-14, half of it is going to be gone because it goes back to nitrogen-14. And so we need to measure how much is in the fossil. And that's what carbon-14 methods do, labs do. They clean their equipment. They know how to avoid contamination. And we have how much carbon-14 is in the fossil or the item that we're trying to do. Could be a cut down tree, what have you. And we're going to see how much carbon-14 is in there. And then we compare that to what we have in the atmosphere today. So that's the key assumption. Remember to look for the assumption. When they give you the answer of carbon-14, how much carbon-14 to 12, what was that ratio when the animal died or the day the tree was cut down? That's what it matched, what was in the atmosphere at that time. But the assumption is that if our atmosphere and our planet is millions and billions of years old, well, over thousands of years, it doesn't matter because it's always been the same ratio for hundreds of thousands, if not millions of years, or very, very close to what we measure today. So if this assumption is true, then carbon-14 dating is a reliable dating method. And I really think that it's not too bad, except that the answer is we have to assume how much carbon-14 was in that sample, like this fossil on the right, when it died and then got buried, turned to a fossil. Now I'm measuring carbon-14 in that fossil, and I'm comparing it to when it was alive, which we assume to be the same as in the atmosphere today. But in reality, it was the same as what in the atmosphere in the time period it died. And the assumption is, was that the same as today? So that's the critical detail here. The starting amount of C14 is assumed to be the same ratio as in the atmosphere today. Because obviously we can't go back into time, measure carbon-14 5,000, 10,000 years ago to get the real starting point. So has it always been the same? That's the key assumption. If this assumption is true, we can get there. But if it's false, then carbon-14 is going to overstate, in this case, the age. Now, one of the reasons we know about carbon-14 is Professor Libby got the Nobel Prize for developing the carbon-14 dating in the 1950s. But he always realized, as he measured how much carbon-14 is in the atmosphere, he found some inconsistency, but he put it down to errors. Here's the quote, according to Richard Milton. he found a considerable discrepancy in the measurements indicating that apparently radiocarbon was being created in the atmosphere somewhere around 25% faster than it was becoming extinct. Libby put the discrepancy down to experimental error, which it could have been in the 1950s. But later, it's been revised and updated. And in the 60s, Libby's experiments were repeated by chemists. The new experiments, though, revealed that the discrepancy observed by Libby was not merely an experimental error. It did exist. In other words, the amount of carbon-14 that he saw, thought it was no big deal, is growing, which means in the past, there was less carbon-14 in the atmosphere. You got it? And in geophysics, a secular science peer-reviewed journal said there is a strong indication, despite the large errors, that the present natural production rate exceeds the natural decay rate by as much as 25%. So this is getting at the heart of the assumption of the final calculation when we do carbon-14 dating. And here's another article from American scientists. We know that the assumption that the biospheric inventory of carbon-14 has remained constant over the past 50,000 years or so is not true. We know it's still being created. It's going up. That means when that fossil, when we measure how much carbon-14 it has in it, we cannot accurately assume that when it died or was buried or the tree sample was cut down, that it had the same carbon-14 as today. In fact, we know scientifically that it had less than today. So this key assumption is false. So carbon-14, the fact if anything is older than 80,000 years, it should have no C14. But we do have C14, even with all the problems with the assumption and the calculation. If we have C14, that is solid evidence that it's not millions of years old. Therefore, coal, if really coal is millions of years old, as they say, I was always taught, it should not have any detectable carbon-14, and the assumption doesn't matter because if it's more than 80,000 years old, you can't even measure it. Therefore, it shouldn't have any. But we do find it. And fossilized woods that are up to 200 million years old, they contain carbon-14, and I'll give you an example. And here's the kicker. Dinosaur bones have detectable C14. All of this without the assumption, without any adjustments to the age calculation. The first thing carbon-14 does, if it's in your sample, it rules out millions of years, period. And we find carbon-14 everywhere. Diamonds, deep earth diamonds that are believed to be 1 billion years old. I remember reading that. You got these, pieces of coal, that were once tree bark, buried deep underground, millions of years of time and pressure and heat changes it to diamonds. And yet, a diamond is not, it's the hardest substance known to mankind. It cannot pick up contamination. The labs know how to keep their equipment clean. And every time a deep earth diamond has been sent to the lab for carbon-14 testing, it comes back with a date. It doesn't come back, carbon-14 dead, can't find it, just as we believe. No, it's got carbon-14. And that carbon-14 means these natural diamonds, if it has any, and let's say it comes back with an age of 48,000 years, it's thousands of years old, and it completely rules out millions and billions. That's the first thing carbon-14 does. It rules out millions and billions of years because there shouldn't be any if it's more than 80,000 years old. And of course, Dr. Baumgartner looked at this data and said, well, carbon-14 is a great support for a recent global flood and the young Earth because we find it in deep earth diamonds. So remember this, carbon-14 can only be used to date organic material, something that was once alive, and yet it's found everywhere, including dinosaur bones, deep earth diamonds, and so on. The first thing carbon-14 does, it wipes out millions of years just by its presence. It's only good to 80,000 years, give or take. So the basic assumption that we also talked about is false. So you bring this in, that the equilibrium of the atmosphere is wrong, that it's going up. In other words, in the past, there was much less carbon-14. That means we are overstating. So if my diamond comes back 48,000 years old, or my dinosaur bone comes back 22,000 years old, the first thing it does, wipes out millions of years, and then we consider the assumption of an equilibrium in the atmosphere. We know that's false. When that diamond was coal, and before that it was a living tree, the amount of atmosphere was much less. When that dinosaur bone was alive, the dinosaur got buried and killed. When it died, there was much less C14 in the atmosphere, so that even if it does come back with tens of thousands of years, you take into account and you can recalculate everything as less than 5,000 years old. So two things. If you got carbon-14 wipes out millions of years, dinosaur bones come back 22,000 years old. Well, why is it 22,000 years old? Because of the assumption of equilibrium. And if I recalibrate, knowing that when that dinosaur was buried, the atmosphere had much less carbon-14, so I compare much less to what it does have, and you get answers under 5,000 years old. And of course, ancient fossils as well as coal, diamonds contain C14 residue. Therefore, they can only be thousands of years old. Wow. Carbon-14 for a decade now has been said to be a young Earth creationist's best friend, and this is why. First, even if you don't worry about the assumptions, it wipes out millions of years. And then when you take into account the false assumption of equilibrium, then you can get your ages from less than 40, 30, 20,000 years down to under 5, because you know that assumption is wrong. Wow. Libby calculated it had to take at least 30,000 years to reach equilibrium from whenever the Earth and the atmosphere were formed. And yet we know, as I showed you those articles, 25% out of equilibrium. That means our atmosphere, carbon-14 and all, cannot be more than 30,000 years old. That is a major scientific, repeatable proof that the Earth is young. One of many, along with the carbon-14 and diamonds and so on. It cannot be millions and billions. Those years were made up to accommodate Lyell and Darwin. Here's an example. Let's look at some rocks that were created since 1980, like the eruption of Mount St. Helens. When these rocks, and if you don't tell them where they're from, you have to do a blind sample, which is correct in science. You send a rock from Mount St. Helens formed at the eruption or at the secondary eruptions in the 1980s. You send that volcanic rock to the lab for testing. It can be dated at 1 million to 2.8 million years old. And yet we know, oh my gosh, we know it's only about 45 years old. And it gets better. Sunset Crater in northern Arizona, we've got some volcanic rocks there. They've been sent to the lab, even though people tell us that they had to be 200,000 plus years old, some up to 1 million. And that's what potassium argon gating says. Oh man, this volcanic rock has been sitting on the surface here for, 250,000 years old. But we know it formed in 1065. We have Indian artifacts that give us that date in about 1,000 years ago. 1,000-year-old rock, and it comes back dated at 200,000. Or some lava flows in New Zealand. Potassium argon says these rocks, these volcanic rocks, are 275,000 years old. Reality, we know they were formed in 1949 or 54 or 1975 when that mountain erupted. Or Hawaii, a lot of volcanoes there. Potassium argon said that some of these volcanic rocks are 1.4 to 22 million years old. And yet we know on the Big Island, that they're about from a volcanic eruption of 1800s, and some even more recent. So there's always bad, inconsistent results. Let's go to Sicily. Everybody knows Mount Etna. You got volcanic rocks dated 140,000 to 350,000 years old. Reality, they were formed when Mount Etna erupted in 1972. Too many problems. In 1993, scientists found wood from trees buried in basalt flows, volcanic flows, 69 feet deep in the earth. Wood samples were sent to 2 laboratories to be carbon-14 dated. Hey, here's some wood. You should be able to do some carbon-14. Give us an answer. And they came back about 44,000 years old. There is a slight range, but they're on the 40,000 years, a little bit plus old. But here's the thing. The wood was encased in basalt within these rock layers, up to 69 feet deep. So they're not disturbed over a long time period here. So the basalt then, which encased the rock, the basalt encased the wood samples. The basalt was sent to another lab for radiometric dating, again, potassium argon, and it came back 44 million years old. Wow. How can you have 44,000-year-old wood buried and encased in basalt that's 44 to 48 million years old? Holy cow. There is something wrong with these assumptions, isn't there? There's another example from Cripple Creek out in Colorado. There's a major mine there, 1,700 feet underground. They found another example of fossilized wood in the mine and also encased in volcanic material, like a lava flow went through a forest and a little bit of the tree is remaining as the lava cooled down. So they did analysis of C14 aging, and the wood sample came back 41,260 plus or minus 540 years old, thousands of years old. But it's encased in volcanic rock that's supposed to be 32 million years old. There's something wrong with the assumptions, isn't there? The wood is C14, aged 41,000, could be even younger, but the rock is dated at 32 million. You see, here's the problem. If the dates are never right when we know the age of the rock, how can we be sure they're correct when we don't know the exact age of the rocks? And yet, old Earth geologists will tell us, well, trust me. No, if you base your theory on a wrong assumption, well, as we learned, all your calculations can be correct, but the result will be wrong. Here's another example. Here's a large rock strata, at least several layers of rock here. You see the person at the bottom, and it must be what, it must be 40, 50, 60 feet tall cliff face. Now, Lyell and most secular geologists would say, if they just saw that, they would say, well, man, that must be 500,000 years old there or more, millions of years old, just these exposed layers, until they know where it happened. Up until that first red line, that entire layer from below where the person is standing was formed in a matter of hours on May 18, 1980. This is the vicinity of Mount St. Helens. On that date of the eruption, that rock layer did not exist. A few days later, there was a secondary explosion, and that whole secondary layer was laid down in a matter of hours. 2 years later, there was another eruption at Mount St. Helens, March 19th, and that upper layer was formed in a matter of hours. Distinct layers showing all the bars. It shows Mount St. Helens has proven you don't need millions and billions of years, not just to get these tall rock strata, cliffs and so on, but they can happen in a matter of hours, but also the canyon. which was cut in 1982 in a matter of days. You don't need eons of time. So how about this question? It comes up when I talk about how young the Earth is. We've got, well, this is a little dated. People now say the population of the Earth, of people, is about 8 billion. So let's say 7 to 8 billion. Can you get 8 billion population with only 8 people alive 4,500 years ago, give or take? Yes, I've done the math. I'm an engineer. You do the math. If, as evolutionists say, modern humans had a population of about 10,000, 250,000 years ago, then you would have trillions, gazillions, quadzillions of people, and we don't have anywhere near that amount of bones. Even taking into account all of the wars, diseases, plagues, you will easily come up with a 7 to 8 billion people from 8 only 4,500 years. And if you try to go back to hundreds of thousands of years ago for modern humans, you get astronomical numbers that make no sense. It's called exponential growth. And that's what our population does, like so many other things. The mutation rate indicates our genome is young. We had a talk on Adam and Eve. That certainly fits. The data today on mutation rates fits that we have a young genome. It can't be more than 6,000 years old. Not much at all. And of course, dinosaur. We've got biological tissue and DNA in dinosaur bones. They can't be millions of years old. Rock strata formation, as we just saw from rocks. And then we've got helium in the atmosphere. I'm going to explain that one here in a minute. And magnetic fields. This refers to the genetic analysis of mitochondrial DNA. And a human origin of 6,000 years old fits all the data. It fits and confounds the idea of 200,000 years, which secular scientists try to say that the modern humans have been around. It just doesn't work, and our genome confirms it. It challenges the whole evolutionary model. I mentioned soft tissue and dino bones. We have whole presentations on this, but this has been a conundrum for long earthers. The whole idea that dinosaurs died out 65 million years ago is defunct. Modern science has ended it. You're not going to get collagen. And today we've got up to 14 different proteins that have been found in dinosaur bones. Those bones cannot be millions and billions of years old. The whole idea of index fossils that dates them is wrong, built on faulty assumptions. And we know that it's there. These tissues were not fossilized. There was real collagen. And every biology student knows how to do the test. Simple stuff. You're not going to get this stuff there. And in 2012, Dr. Schweitzer even said she isolated some dino DNA. Now this is becoming more mainstream. DNA is a fragile molecule. And in 2012, there happened to be an article by the Proceedings of the Royal Society published that says, what's the decay rate of DNA? Oh, it can't last for 100,000 years, let alone 65 million. Then we have trees petrified in short periods of time. Going back to Mount St. Helens, we have trees that have sunk in Spirit Lake. And if they went back, Steve Austin was one who actually went scuba diving, looked at these, and they're petrified. You don't need millions of years. And then here's another interesting thing. Helium in the atmosphere and in granite rocks. Now, as we mentioned, the helium goes to lead, but it actually goes through multiple stages, at least 6 stages. And in every stage, alpha particles are released. And it basically combines and makes helium, the basic inert gas. And as uranium decays, we are losing these helium nuclei, and then they pick up the radius. So we have helium in the rocks as the uranium decays, and then it eventually forms lead, and we have enough confidence that this is true. We also know that there is alpha particles released, becoming helium atoms. So we have helium in the rocks, which are porous, and helium is a very tiny little atom. It goes through the rocks and into the atmosphere. So we can do some measurements on this. The radioactive decay of uranium to lead produces helium atoms. Helium does not remain long in the rocks. It migrates rapidly to the surface and into the Earth's atmosphere. Now, if the Earth is really billions of years old, we should not find large amounts of helium in the granite, the rocks. And because it's going quickly through the rock, over billions of years, in fact, we should find a lot of helium in the atmosphere. A lot. And we can actually measure this. If the Earth is billions of years old, we should find corresponding data that fits. So here it is, helium atoms being released through radioactive decay. They migrate through the rocks, go into the atmosphere. And you know what? We can measure that. There's not enough helium in the atmosphere for an old Earth. Yes, I know very well that helium is so small in light, it escapes into space. But you can run the numbers. We know how fast things should go. It gives a maximum age of 12,000 years for the atmosphere. Now, that's the maximum age. Remember, Carbon-14 said our maximum age was 30,000. So we're all talking in the thousands, even if you take into account some helium going into the atmosphere. But notice that there's still going to be some helium in the rocks as they migrate through and make their way to the surface of any land mass. Now, in 1974, core samples from a major drilling operation, almost 1.8 miles deep, was done in, I think it was done in New Mexico. And in the granite, you can find these crystals called zircons. And the zircons is where you find some of the uranium turning to lead. So it's releasing these helium atoms. That's the samples. Deep earth embedded in the biotite are radioactive zircons. So based on radioactive dating of the zircons, the granite was dated at 1.5 billion years old. Again, there is the nuclear decay going from uranium to lead, releases every step along the way an alpha particle, which becomes a helium atom going through the rock and into the atmosphere. Well, when they studied these zircons, they looked at these samples from deep underground, almost 2 miles. There was a lot of helium in these zircons, despite it being small, hot, and allegedly old. So it seemed, and this is a routine finding, these findings are often published in the details and the footnotes of scientific articles where they're studying something else, and they gave a measurement of the molecular makeup of some of these zircons. And as people looked at the data, it wasn't necessarily what the article was about, but as they looked at the data backing up the article, it seemed like there was a lot of helium in these zircons. So they studied with them because we did not know until more recently how long does it take for helium to go through the zircon once it's formed deep inside to get out of it. So scenario one, if the helium migrates through the zircon, through the granite, very slowly, then the rock could be old and accounts for the large amount of helium. Got it? It diffuses slowly, so there's still a lot in there as it's releasing it. It's still stuck in the rock. But if it diffuses quickly, in other words, the helium, the atoms that are forming are diffusing out of the rock, then why is there still so much helium in the rock? Well, that means if it's coming out quickly and we still have a lot, it has to be recent. So you have a very young age of the rock. And so this was then studied. Nobody had done these analysis of how fast does helium go through zircon. So predictions were made on these two scenarios. If the rocks were very slow, that means the rocks could be, what we're told, 1.5 billion years old. And it does diffuse at different temperatures, slightly different. So we're looking at a diffusion rate down in the lower portion of this graph, where at different temperatures, the diffusion rate would fit a 1.5 billion scenario if it's diffusing slowly. And that's the purplish 1.5 curve based on temperature. So if temperature was 100 degrees, it would diffuse very slowly, and then you can see the rates from there. But calculations can be made. Let's assume the rock is 6,000 years old. Those zircons, well, we know how much helium they have because that's what we're measuring. It looks like a lot. If the diffusion rate was fast, then you would come up with this kind of diffusion rate to match what's in the rock. And what would diffusion rate be to give us the results that we see today? So these are predictions. We didn't know the diffusion rate, but if the Earth is young, it's going to be a fast diffusion rate, the red line, based on the temperature. If it's a slow diffusion rate, it's going to be the purple line at the bottom. That's how fast it goes through. Okay, so Dr. Russ Humphreys writes that, and he's a physicist, an award-winning physicist, worked at in laboratories, government laboratories in New Mexico. And in 2001, they commissioned one of the most respected experimenters in this field to actually measure how fast does helium go through these zircons from the same borehole. They were given samples, so we're not mixing this up. So they did this in a blind test example. Money was raised to pay for this testing, which no one had done before. So the experimenter didn't have a prediction. They had no idea what the results were. They just wanted to do a blind experiment. What is the diffusion rate? Okay. Well, in 2003, took 2 years, they got the results. Now, here's a reminder. Here's the two graphs. Red line is a fast diffusion rate, so the rocks can only be about 6,000 of years old. If it's a slow diffusion rate, purple line at the bottom, then that would fit a prediction of what they say the rocks are, 1.5 billion years old. Now, these are not close numbers. This is an exponential graph, so we're off by a lot here. So the results ought to tell us something. What is the actual diffusion rate in zircons of helium going through? And what do you think the results were? The results were put on this graph in blue. And there's the data. This is from an independent lab. What is the diffusion rate at various temperatures of the helium through zircons? The data fits the 6,000-year-old graph, and that is by a factor of 100,000 different than a billion years. Folks, this is real science. It's proving that based on how much helium is in the zircons, let alone how much is in the atmosphere, that these rocks cannot be 1.5 billion years old. There's something wrong with that assumption. The data fits a young Earth. So now that we know the diffusion rate, which is fast, there's not been enough time for the helium to diffuse out of the granite. The measured diffusion rate is fast. It matches the young Earth prediction by a factor of 100,000, and it fails the old Earth prediction. This is hardcore data. The evolution model of billions of years does not match the data, the creation model of a young Earth. And of course, this also explains, if it's a fast diffusion rate, why there's not enough helium in the atmosphere, because there hasn't been enough time for it to build up. Both sides of this. A lot of helium in the rocks, not enough in the atmosphere. fits a young Earth after all. If you want to read more about it, get into the details, if you're scientifically minded, you can get into the rate group. Thousands, Not Billions is their published book. But let's look at one more thing. I think we've got some time. Let's look at magnetic fields. You know, the Earth has a magnetic field. It's a powerful witness as well. We've been measuring Earth's magnetic field for over 120 years or more. And it's going down, basically the right side of this graph. We know that there is a steady decay rate, exponential rate of our magnetic field. It's getting weaker. And if you go backwards, as Dr. Humphreys, PhD in physics, calculated several years ago, the Earth would be too hot to generate much of a strong magnetic field. The only theory for the origins, rapid reversals, fluctuation, and the decay of the Earth is a creationist theory, a theory that fits the data. He says Earth's magnetic field has to be less than 100,000 years old, most likely less than 10,000 years old. Dr. Humphreys was raised in an atheistic home. He did not believe the Bible growing up, but as a graduate student at LSU, became a Christian, read the Bible, and right away, because of his work on magnetic fields, saw that the data fits a young Earth. Here's a more recent picture of Dr. Humphreys. He is research in physics, light and magnetism. He's published 20 papers in secular scientific journals and done many other things. He's an award-winning physicist at Sandia National Labs. He was involved in all the rate studies and is a premier physicist. There's an interesting thing that he did back in the 1970s. Voyager 2 was a space probe launched in August of 1977 when we realized that in the coming decade, the outer planets would be arranged just right so a space probe could go out and visit a little bit, I think, Jupiter, Saturn, Uranus, and Neptune. Now, Uranus and Neptune are far out there, and we cannot measure their magnetic fields from here on Earth. The bigger planets, I think we had an idea. But since we had no idea what Uranus and Neptune had for a magnetic field, if any, they were going to measure it with the Voyager 2 space probe. And it got there in 1986. But before it got there, all of the scientists, geophysicists, and others, NASA scientists were making predictions in print. Dr. Humphreys also made one in print before 1986, based on his work that the Earth has to be less than 10,000 years old, and it has a magnetic field similar to Earth's in its formation. And so he made all his calculations on magnetic field decay and came up with an answer and published it before Voyager 2 got there. Well, we got the data, and Humphreys' model was the only one that was right. He was the only one. All of the NASA scientists and others around the world who did publish predictions like Humphreys, they were off by a factor of 100,000 into the millions. They were way off because they based their calculations on the assumption that the solar system is 4.5 billion years old, that evolutionary model. Humphreys' calculations were based on the assumption that the Earth and the solar system is 6,000 years old. He made his calculations, he put it in print, he was the only one right. Come on, in science, this is big. You make a prediction like this, you're the only one right. He should have won the Nobel Prize for physics that year. Of course, they wouldn't give it to him because he became a known creationist by then. But this is science, this is real. And then he did it again. Mercury. Mercury is a small planet, the first one around, closest to the sun in our solar system. And it was, by all ideas, it shouldn't have a magnetic field. It's so small. And of course, if it's 4.5 billion years old with the rest of the solar system, if it had one, when it formed, it should be long gone. It's just a rock, hot on one side when it faces the sun and cold on the other. And yet, 1975, Mariner 10 detected a magnetic field. So it shouldn't have one if it's billions of years old. And then Dr. Humphreys made another prediction. He said that if we ever go back to Mercury after the Mariner flights, we will find that it still has a magnetic field, but it's decaying rapidly. If you believe in billions of years, then a few decades wouldn't matter. It should be about the same as was detected in 1975. And we did go back in 2008 and 11. Messenger space probe went around Mercury and made more calculations measuring the statistics on the strength of Mercury's magnetic field. They didn't come out and say it in the NASA data, but it was all there. And you could figure out magnetic field of Mercury. And it turns out that it was fitting his prediction. The latest spacecraft data confirmed a young solar system. Here's Mariner's, a graph with Mariner's data, plus or minus statistical error range for Mariner's data in 1975, and then the Messenger data in 2008. And it declines rapidly, enough that the error rates are out of the range, and so these numbers are significant. What we have is a magnetic field of Mercury, which it shouldn't have one to begin with, but it's also declining quickly. In 2011, Humphreys wrote, Mercury's magnetic field has weakened by nearly 8% in the past 36 years, an astonishingly fast decrease. And that supports a 1984 prediction he made that if we go back, it's going to be showing to decline quickly. In fact, the fast decay rate of Mercury implies the crust was magnetized only thousands of years ago. So Mercury has a magnetic field, so it shouldn't have one, but it does, and its rate of decline. Both of these facts are consistent only with a 6,000-year-old solar system, not with a solar system billions of years old, which is, of course, the old Earth assumption. Keith Wanzer is also a PhD in physics, and he wrote, I am convinced there is far more evidence for a recent six-day creation and a global flood than there is for an old Earth and evolution. I hope you get just an idea of all that's available. If you really want to dig in some of the more details of modern research on radiometric dating, ICR has an excellent book by Dr. Krups, who is a atomic scientist. He worked at Argonne National Labs outside of Chicago. He is an atomic scientist. He wrote this book, Rethinking Radiometric Dating. A very recent book just came out this year is on the age of the Earth. You can read more about it from the ICR bookstore. And then, of course, 101 Evidence for a Young Earth is an article by Dr. Humphreys on creation.com. You can just go to their page and then search 101 Evidences or a Young Earth and get some more interesting data, a lot more evidences that we have time for. But here's just a few that recap what we did show you. Carbon-14 ratio in the atmosphere is showing that it's declining, and it's declining fast, consistent with an Earth that's only, or an atmosphere that's only thousands of years old. We've got carbon-14 in diamonds, coal, dinosaur fossils even. We've got helium in its atmosphere, which is not enough. We've got helium in deep Earth zircons, which is too much to be billions of years old. We got sodium in the oceans. We've got the rapid disintegration of comets. They can't be billions of years old. We've got erosion of the continents, sediments in the ocean. We got the existence and decay of planetary magnetic fields that fit a young solar system. Everywhere we've gone in the solar system with NASA space probes is consistent with a young solar system. And then we got the radio halos. I didn't get into that. And the recession of the moon. There's many, many more. So who believes in the literal six-day creation? Scientists from around the world, probably thousands. You see, the Earth has not been scientifically proven to be billions of years old by any means. That's an assumption to fit old Earth beliefs of Lyell and Darwin. And the Bible does teach six-day literal creation. Genealogies tell us that it can't be much more than 6 to 10,000 max. Long age assumptions and human doubt about Noah's flood led the groundwork for these false assumptions. And new evidence from nuclear decay, DNA, astronomy show Earth cannot be billions of years old. And of course, many excellent PhD scientists around the world believe this, and they believe the Bible. In many cases, it's just because of the science. So it's better to trust in the Lord than to put confidence in man. Man's ideas and words are always changing, but the word of God changeth not. We can trust it. I'll be ready to take some questions here in a second. Can I take a quick pause while you wrap things up, Donny?
Absolutely. Helmut, well deserved. You take your time, brother. You take your time. Okay. That was excellent. And we have a lot of questions. What I'll do is screen share. And when Helmut comes back, he can let me know. But here are a few of the rescue devices and objections that I see in the chat on a lot of what Helmut has presented. And so I've labeled a couple of these slides evolutionary rescue devices. So the critics have claimed carbon-14 and diamonds and coal, the C14 that shouldn't be there, can be explained by in situ production through uranium and thorium decay. Coal acts like a carbon sponge. That explanation doesn't hold up quantitatively for neutron capture to produce measurable C14 at the levels consistently observed. You'd need thousands of times, and we've addressed this on numerous occasions, including with Dr. Jason Lyle, a PhD astrophysicist. And so many scientists have pointed out that you'd need thousands of times more uranium and thorium in or near the sample than actually exists. Diamonds in particular are nearly pure carbon and crystalline, meaning they act as shields against infiltration of uranium and thorium bearing fluids. Thus the in situ, and this is probably one of the better follow-up objections that I've seen, but it's been addressed. Helmut cited the RATE team and the work that they've done. We've had many associated with the RATE project on the channel. Dr. John Baumgartner, for example, we've had him on for a 4-hour seminar on CPT where we discussed this issue of carbon-14 and coal and diamonds. And so thus the in situ explanation fails both chemically and physically. It's not a testable mechanism. It's a rescue device. And so even the best rescue mechanisms, Helmut, good to have you back, brother, have been addressed, but they've been addressed by the RATE team. Now, their primary book on the issue is large. It's heavy on material. It's technical, but the answers are there. And it just shows me, Helmut, how powerful the evidence is that you presented in your talk, including the helium and zircon crystals. That's another amazing piece of evidence that limits the age of the Earth. But okay, that was one of the rescue devices that I've seen. Helmut, since you're back, brother, let me ask you a couple of these questions that came in directly from the chat. And so you showed examples of newly formed rocks. Correct me if I'm wrong. Newly formed rocks, for example,
relatively new. Yes.
Yep. Like Mount St. Helens. Firstly, what I wanted to say is this should definitely be a go-to video for people that want a good, technical, comprehensive answer to the question of dating methods. Why thousands, not billions? Because you touched on many of the best, not only arguments to dating methods, but also arguments for a young Earth. Magnetic field decay, for example, being one of them. Dinosaur soft tissue. So anyways, what they'll follow up with, Helmut, is this. And so we have a critic in the chat. They'll say, sure, we've dated rocks of known age, relatively newly formed rocks, and we get ages extremely inconsistent. Millions of years, even though they were roughly just formed. We as creationists like to ask the question, why should we trust rocks of unknown age? We never saw them formed when we can't even derive dates correct dates from rocks of known ages, and we've seen them formed. And so they'll point to a couple examples. Here's one that I've seen, and I'm curious as to your thoughts. The analog zone, appreciate it. He says, what about Mount Vesuvius? Precise dating of the destruction of Pompeii, so it goes back to the destruction of Pompeii, proves argon to argon method can reliably date rocks as young as 2,000 years. So in other words, they'll point to this example. There's a couple others where they say that the dating methods, in this case, argon to argon, actually gave us a correct date because we know when Pompeii occurred.
Yeah, I'm not familiar with that testing. I know they came up with the argon-argon method to try to correct some of these obvious things wrong. But, you know, you're talking about something that's roughly what, 2,000 little plus years? So, whoopee, you got one little sample right when you knew the answer. And so I don't know how they adjusted the argon-argon method. I'm sorry, I can't speak to that. But like I say, whoopee, I've got 1,000-piece puzzle and 980 pieces or more fit a young Earth. And you're telling me, well, I've got one here in the unknown area that might fit a assumption about young Earth or even old Earth radiometric dating, but so what? It's not enough to overcome the rest of the evidence. And if they do got that a little calibrated better, you're still only talking thousands of years, not millions.
Exactly. No, I agree. They'll point to one good, so-called good argon to argon date like Vesuvius, while ignoring dozens and dozens of failures like Mount St. Helens and other ones that have been cited. And so to me, that's not a confirmation of reliability. It's the exception that proves the rule. They got one or two lucky ones, but dozens of failed ones.
We need to also research what calibrations they did to come up with the known answer. And unfortunately, in modern science today, there's a lot of funny games going on, and even secular scientists bemoan that. So what calibrations were done, what adjustments were made, and just how did they modify that technique? Those are open questions. And again, the important part is it doesn't negate the big problems they have.
Right. If the system only works when it's already calibrated by known ages, then what are the calibrations? What are the flaws in that? You know, we actually have Dr. Andrew Snelling on the program next week. And so that's a specific point I'll be bringing up to him. That's for sure. And because I'd be curious. So, okay. Next question is this, Helmut. We addressed one rescue device for the C-14 found in diamonds, coal, so on and so forth. That shouldn't be there if the Earth is billions of years old. Here's a major challenge they'll point to us, especially in debates. We host a lot of debates here, Helmut.
Okay.
And they'll say, okay, so we get incorrect dates, millions of years, billions of years, but why are we still getting ages of millions to billions of years? Even if those are just relative and absolute and not absolute, why are rocks lower in the so-called geologic column, according to them, this is their assertion, consistently dating older than rocks at the top?
Oh, I think Dr. Snelling actually addresses that in some of his detailed research. I mean, the relative dates can give you an idea for what's slightly older than others, and I don't think any of us have any problem with that. It's just the absolute numbers that are way, way off. So, yeah, obviously a rock lower is going to be slightly older, even if it's only a few years older than the ones on top, or even 1 year. So that's just a matter of confirming, and Dr. Snelling, I think, will agree with you that it gives you some of the idea of relative ages, but absolutely nothing on absolute ages.
So would you say then at creation, in the same way that, you know, you've talked about genetics and Adam and Eve, the original created kinds, being created in being created genetically heterozygous. That fancy term, basically, they're created in a state of DNA diversity. They have pre-existing DNA differences. Okay, so did God also create the original rocks in various ratios of atoms? And what I mean by that is, if a scientist were to come an hour after creation, Helmut, and take one of these rocks that were just created and date them, would they be finding a mix of, let's say, uranium and lead atoms? And so to them, oh, look at these rocks, millions to billions of years old, even though they were just created. Is that partly one of the reasons why we still get ages of millions to billions of years old, even if they're not that old?
Well, that's certainly a possibility. I don't think we can go back and say either way on that kind of scenario. I think that what has been established is that there was a burst of radioactivity around the time of the flood, and with the fountains of the deep and the breaking up of the continent into the continents and continental drift, some of Baumgartner's work, I think you might find that, but I suspect that the immediate creation rocks would have had very low level radiation. Otherwise, you would have had in succeeding generations after having a higher mutation rate leading to shorter lives. And we don't see a significant drop in the lives of the patriarchs until after the flood. So I think a lot of that burst of radiation occurred during the flood year and years afterward. That it seems to fit the mutation rates, that there was a burst of it. I've seen data on like the Iceman, the guy that they found frozen in the Alps, that they did some check on his mutations. And we have an idea from the surrounding area of how old that would have been. And he already had a lot of mutations, but that would have been after the flood. So I don't see that as a valid thing, that those rocks right after creation would have been old. I think they would have had very low, if any, amount of radiation. I think that really happened in the lead up of the flood and the judgment of sin. And God just decided that, when people live to be 800-900 years old, they just get into too much trouble. And then that's when he started capping it at 120. And we can see that decline. It fits an exponential decline with the mutation rate after the flood. That's my thought. It's a very hypothetical question, but that's how I would look at it.
No, I think those are some good and helpful thoughts. And so, what if I've seen differences in opinion on this issue, where some creationists have said, well, maybe the origin of radioactivity was a deep rock phenomenon, and so radioactivity could have been I'm curious as to your thoughts on this. So it could have been present, but beneficial in terms of helping to heat the earth, warm the planet in a beneficial way that could provide nutrients and so on and so forth to plants and life. But once the flood occurred and the fountains of the great deep broke open, maybe those radioactive elements came to the forefront, leading to damage. So
to be honest, I haven't heard that, but that makes sense to me. You would need a source of heat deep in the earth just to get Earth's magnetic field. I mean, that's relied on molten iron in the core of the earth, spinning. And so, yeah, that could have been the initial requirement, deep under the earth, keeping molten iron to give us a magnetic field, which is protective against cosmic rays and has been. It's just that it's declining now, and probably after the flood. So, yeah, there's some plausibility there.
Yeah, because the critics, and I appreciate that response, the critics will say this: okay, if one of the assumptions that's so bad, Helmut, because we talk about how there's 3 to 5 major assumptions behind dating methods. If one of the assumptions is, well, we assume the rate of decay is constant over time. Well, if we say that during the flood, I'm not saying this is a bad argument. I think we have good evidence for this. Helium and zircon crystals, radio halos, fission tracks, for example. But they'll say, okay, if you put a lot of that decay during the time of the flood, let's say you have 1 billion years of worth of decay in a single year during the flood, to explain why rocks lower date older than rocks at the top. And as creationists, we'd understand that as relative dating rather than absolute. They'd say that's going to release in a year span a lot of heat and energy and even radiation, where all of that heat released would actually cook the planet, kill the ark animals, kill Noah's family. And so the critics will say that alone is good enough reason to believe that decay processes have been relatively constant over time. What's a good response to that in your opinion?
Well, I think your idea, or where I don't know where you got it, but there was a lot of decay going on deeper in the earth, that those rocks moved forward, came closer to the surface during the flood, because that was a cataclysmic event involving a lot of volcanic activity on the earth. We know that from the super giant volcano that we have leftovers of today. So, yeah. Plus, I don't know. Baumgartner admits that if you did it all at the flood, it would be too hot, and that maybe God just kept it cool because he does intervene in human history.
Right.
But again, it could be because of exactly what you said. I like that solution, actually, that there was activity deeper down. It just came further up, but there was some advance. There was some advanced decay. But we got to also remember, and I don't know the calculations, but water is a great protector against radiometric radiation.
Right.
That's why all of the nuclear reactors we use are full of water to absorb that radiation. And exactly how much they can absorb over which time, and you consider a whole ocean. And so I think there was some accelerated decay. I think some of it came closer to the surface of the earth, as you suggested. That would fit. And it would not contradict all of the other data evidences that we have, that we talked about, the carbon-14 especially, that indicates a young Earth and a young solar system. We got to remember, I don't have time to go into everything, but every planet that we have sent the space probe to and analyzed the data indicates every planet, including Pluto, where we've been to, New Horizons spacecraft went there, indicates these planets are young, including some of the moons of Jupiter and Saturn that we visited.
Right.
When we have the data, the old Earth assumptions fall apart. Are there still open questions? Sure, but they're pretty few compared to the hard data we have.
We have the bigger picture. We have the bigger picture answer, with some of the minor details and minor questions yet to be solved. And so I appreciate that response.
So we need ongoing research, no doubt about it.
Right. And if we didn't, that would remove all the fun. I mean, it's a great time to be a biblical creationist because we have answers, but we also have a lot of work and research that we are doing and can be doing that makes being a creationist fun. Because if we had all the answers, what else would we do, right? So I first heard this from John Mackay. He's a creationist geologist, and that sparked my interest. So I made notes based on what he said about the possibility that the invention of radioactivity, I've got it up on a slide here, was likely, it's just a hypothesis, perhaps it's true, perhaps it's not, was likely a deep rock phenomenon. Its intention was to keep the earth warm, or as you said, assisting with the magnetic field as well. The heat would have kept the temperature of the earth stable during creation week. In the pre-flood world, people overlooked the usefulness of radioactivity. It's only after the flood, when the fountains of the great deep break open and the radioactivity is brought to the surface, to become a threat to us. So that would probably help to remove at least some of the heat and radiation from the flood. So we still have some accelerated decay at the flood, but not as much as the critics might want to harp on.
Yeah, we know we have got too much other evidence that leads us to the conclusion that it can't be that old. So yeah, we got one or two outliers that we can work on. And McKay's work might be very helpful here.
What are your thoughts on critics that say to the C14 in diamonds, coal, fossils. I really enjoyed that portion of your presentation. How you did a lot of research for this. This was great. They'll say, well, it's contamination in the lab, instrument contamination. What are your thoughts?
Well, I tried to mention that with just maybe a sentence. If that was true, if contamination is that bad that you're going to find it consistently giving you young Earth data on diamonds and dinosaur bones continually,
right,
then you might as well throw carbon-14 out. Or you're basically saying that the carbon-14 labs don't know what they're doing, that they can't keep their own instruments clean. I think they can, and they give good results, and they give their, plus or minus range potential statistical error. So that's just an indictment on their own industry that says they can't keep their stuff clean. I think that's just a silly explanation. It's just too consistent with every dinosaur bone that's been measured. It comes back thousands of years old. Every diamond, when it comes deep in the earth, even, what the rate team worked very hard to do and paid for, show that they have the carbon-14 still. So we're talking thousands consistently, much too consistent than to blame it on contamination.
Right. I think you nailed it. I mean, they subject those samples to repeated harsh treatments in acids and make sure that the samples are blank, essentially showing, I've heard some creationist scientists say that all of this considered with how the lab does things, their protocols, that the C14 must be intrinsic to the diamond, not due to instrument contamination or environmental contamination. Helmut, this is from Dr. John Baumgartner. He gave an excellent presentation for Logos RA.
Yeah.
And he got all of this.
I'm a member, but I missed that talk.
It was good. Yeah. And you touched on a lot of it anyways here in your talk. But he pointed out that the C14 value that you find in these samples corresponds to 1,200 times the AMS detection limit. The way I understand that is it can't be background noise.
Yes.
It's far above that.
That's the point. You're finding too much, too consistently, to toss it up to contamination.
Right. And you find, I like the way you put it, consistent. We find consistent amounts. We find a high C14 signal all throughout the geologic column in basically every layer in multiple different kinds of samples, diamonds, coal, fossils. And so it's kind of a stretch of the imagination, isn't it, Helmut, to believe that just modern carbon somehow got into all parts of the geologic column, infecting all of these samples to give false numbers. That's kind of hard to believe, isn't it?
That's very hard to believe. If we only were talking about 2 or 3 outliers, I would say they have a point, but it's not just 2 or 3 outliers. It's consistent, and it's too much to be a little bit of contamination.
You mentioned the helium and zircon crystals. As we start to wind down, critics have argued that, well, the only reason you're getting, and you showed the graph and you showed the data that gives us 6,000 years plus or minus 2,000 years, if I remember correctly, from Dr. Russell Humphrey's paper, but very close, under 10,000. That's incredible. Based on known helium diffusion rates, how much helium we find in these zircon crystals. Helium's a slippery atom. It should have largely escaped into the atmosphere.
The diffusion rate was not known until they did that. And the lab that did it, the owners, or the people involved there, as I understand it, are old Earth people, but they stand by their results. They said, this is our scientific experimental results. We know what we're doing. And these are the answers, like them or not.
Like them or not. Yeah. Like it or lump it. So critics have said there's several, it's interesting. I did a video somewhat recently with Michael J. Ord, and we focused a lot on the helium and zircons, and we had a popular evolutionist do a response to it. It's got over like 100,000 views, but it's funny because his argument, in my opinion, was just so bad. It's like, is this the best they have to offer? But they basically say, well, you're only getting those numbers because Russell Humphreys, the rate team, they're assuming constant rates throughout all of geologic history. And so if you actually account for differences in temperatures throughout Earth's history, then you're not going to get the 6,000 years. I'm curious as to your thoughts on that, Helmut.
Well, if you recall, the prediction and the actual data was temperature dependent. And those two curves, a fast or a slow diffusion rate, they look close on a little graph, but that's an exponential graph. So you're talking a factor of 100,000 between the curves, and that little bit of Earth history that he's trying to point up to should not have varied that much in temperature, especially if you've got life living and evolving and thriving on the planet, as they believe. So you cannot play too many games with the temperature, otherwise you destroy the life on the surface of the planet. That's has to be there even in their own timeline. So and the data itself was significantly different. The answers were way different. So I don't, it's like you said, he's trying to have his cake and eat it too, I suppose.
Yeah.
He cannot show anything different. The temperature differences are there. The lab measured them at different temperatures. So the curves are just too far apart, no matter what temperature range you want to throw at them.
You nailed it. I mean, that's perfect. These critics, if they weren't responding to us, the fact that they are responding to these arguments, Helmut, shows that they understand how dangerous these points are to the old Earth paradigm. And if their best rescue mechanisms have already been addressed, yet they're still repeating them, as you've shown, and Dr. Russell Humphreys, I love this article. It's on creation.com. Dr. Russell Humphreys has a large table on there, Helmut, and it's refuting the critics. And he goes through all the critics one by one, what they say to the helium and zircons, and then a quick rebuttal to it. And so on this issue, I summarized what he said, Dr. Humphreys. And so basically they looked at whether it was hotter or colder in the past, look at these fluctuations in temperatures, and none of it works, even in their best case scenario. If critics say it was hotter in the past, that makes diffusion faster and their problem worse. If they say it was colder in the past, that contradicts the measured geothermal data and requires billions of years of radioactive decay with no heat production, which really doesn't make any sense. And so regardless, we get that roughly 6,000 to 10,000 years from known helium diffusion rates. I think that's incredible, Helmut.
It is. And of course, we've got so many other things like the early faint sun paradox. Carl Sagan was trying to solve that before he died, and he couldn't. Basically, that if you go too far back in history, and we know that the helium is being consumed in the fusion process of the sun, not helium, but hydrogen is being consumed. And those hydrogen atoms, as they get consumed, they have a little more room. And so that makes the sun hotter as it burns, at least in this phase of its supposedly evolutionary life. So you can't argue against that. That's known. And if you go backwards, the sun would be cooler because it's getting hotter. So if you go backwards, it's getting cooler, and you go back just I forgot the number, 1.5 billion years, when life is still evolving on the planet, supposedly, then the Earth is too cold.
Right.
So yeah, it could be colder, but it doesn't work for them. There are so many measurements that we've taken, and over 120 years now, from magnetic field, the early faint sun paradox, it just doesn't fit. The Earth, if anything, was warmer according to the fossil record. So it just piles up. And they've got rescue techniques, or at least propose them, that either don't work or are in conflict with each other when they try to apply them all. And yet, when we look at it, we're getting a consistent worldview that not just this planet, but the solar system cannot be billions of years old. And once you lose the billions, Evolution story is over. Why not go with the Bible and trust Jesus as your Savior? Because that is the answer. We do have sin in this world, and we need a Savior. That fits, that biblical worldview fits science, it fits human history, and it fits our condition today. You just need to accept it.
Amen. Those are some great final words. 2 hours flies by with you, Helmut. I love how comprehensive and informative your presentations are. I'm already looking forward to going back and re-listening to your talk. And you cited a paper, and then you had a separate slide with a sample of those, but 101 pieces of evidence for a young Earth. And even in this Q&A, we've just discussed, somewhere between 5 and 10. Yeah, a couple dozen that the evolutionists, we've looked at their rescue devices, we've examined how they respond, and they don't work. And so what about the other 80 or so pieces of evidence for a young Earth? So, brother, and I like the way you said that. Take away time from them. Well, you're not going to get fish to fishermen, bacteria to biologists, goo to you in 6,000 years. That's why they require time. You take time away from them. You also take common descent away from them at the same time.
It's all gone. It changes everything. And that's why they get so emotional trying to defend it, because it gets to the heart of what they believe. They believe with all their faith that dinosaur bones are 65 to 80 million years old. And if you take that away, then the whole timeline of evolution collapses. And why not just say, I was tricked. I was fooled into believing billions and billions of years just so Darwin could be right. But Darwin's theory doesn't work, whether it's just modern genetics or even the timeline. Nothing works that's needed to make it a real theory. But it's not even a theory. Modern science, 21st century science, has decimated the 19th century Darwinism. It's decimated it. And let's just admit it. Admit it, that maybe the Bible's right, that I do need a Savior. And that's Jesus Christ, who died for me and rose again.
Amen. And it's presentations like these, it's talks like these that hopefully will remove the blinders, get people thinking. We appreciate all the critics and skeptics here tonight. Helmut.
It's good to ask questions.
Right.
If you got something bothering you, ask it, and maybe we have a good answer. Maybe we don't. Maybe it is. More research is needed, but don't ignore the rest of the evidence.
Perhaps it encourages a research project, or we give them an answer. And so during your talk, there was almost nonstop live chat debate between critics and non-critics. I was even getting in on it. So that's good. This is generating discussion. It's generating thought-provoking and energetic discussion. That's okay, because people get passionate, because this is the topic of origins. And there really is nothing more important than this, including the question, where will you spend eternity and how will you spend eternity? So Helmut, I appreciate you doing this, brother. I know how busy you are. And so I always look forward to getting to hang out with you for a couple hours.
I appreciate it too, Donny. I know you get to talk to a lot of people, so you've picked up on a few things that I have not heard yet. But I hope overall that everybody got a pretty good view of why this planet cannot be billions of years old. So God bless you. I do have to go.
Yes. God bless you, Helmut. God bless those in the audience. I appreciate the feedback, the comments, the support, the back and forth discussion. Share this around. The truth is important. Critical thinking is important. And so share this around with your friends and your family. And for now, Stand for Truth is signing off. God bless all.